because it's related to the exponential, and an exponential, it's always a positive base, and it's equal to a positive number. So if you have a log of things being multiplied together, you can break them apart and do each log and add the logs. If you have the log of things being divided, you break them apart by subtracting. If you have multiple things on the bottom, if there were a z on the bottom as well, you just subtract that one off as well. So anything from the denominator gets subtracted. Anything from the numerator is added. And power property, if you have something to a power, that can come down in front as a coefficient. So we're going to use those properties to rewrite some expressions. A lot of times it'll say expand or condense. So it might say expand this. If you want to break it apart, if you have the log of things being multiplied together, how do we expand it using those properties? Look at your product property that we wrote down yesterday. What do you do if they're multiplied? You have to write the log base 7 each time. So it's log base 7 of 8 plus log base 7 of 6. And if either of those were something we could easily evaluate, we would. Like for instance, if one of them were log base 7 of 7, we could do that. What is log base 7 of 7? That cancels and just leave you with a 1. Okay. If I said log base 6 of 12 over 5, how would you expand that one? So we would say log base 6 of 12 minus log base 6 of 5.
So you can just do LG for short.
No, you need LOG. Sorry, I think my first one was just sloppy, but you have to write the whole.
Oh,
I kind of wrote my O on top of my L on that one. And you have to include the base as you do it. Because if you have a log with no base, what is that base?
10.
That's 10. So it's different. So make sure you are including your bases as you
I
go.
understand exactly what log stands for.
It's basically saying, it gives you an exponent. So log base 7 of 8 is saying 7 to what power equals 8. So it's representing what that exponent would have to be. All right. We're going to be solving more equations with logs, so we'll need the properties then to break it into things that we can solve. So that's kind of why we're working on these today. All right, if I said log base 2 of the cube root of 9. A cube root is what power? 1/3. And properties of logs, what can you do with that exponent? Look back at the properties we wrote down. We have product, we have the quotient. Just turns into a coefficient. So that's 1/3 times log base 2 of 9. If I said log base A of the 4th root of r cubed. Log base A of r, yep. 4th root of r cubed is r to the 3/4, and properties of logs, that exponent can come down in front. So 3/4 log base A of r. Log base A of the square root r cubed s squared divided by t. So first of all, let's kind of figure out how we might rewrite this. A square root is what power? So all of this was under the square root. So all of this is to the 1/2 power. So if I'm trying to rewrite this, we have a couple options. We have to break it all apart. So why don't we simplify what we have first? If you have a 1/2 power in front, you could take that to each individual, we have the 1/2 power, so we could take it to each individual term or bring it down at the front. I'm just going to simplify up here. If I distribute that 1/2 to each of them, then it becomes r to the 3/2, s to the first, 2 times 1/2 is 1, and t to the 4 times 1/2 is 2. So now, if I want to start breaking these up, how many logs am I going to have to write? 3, 1 for each variable. So I would have log base A, r to the 3/2. Would you guys be okay if I went ahead and wrote the 3/2 in front of this log? Yeah. S is also on top of the fraction, so we're going to add log base A of s. T is on the denominator, so what do we have to do with our t? Right, anything on the bottom gets subtracted just because things on the bottom of a fraction is like a negative exponent. So that's log base A of t squared, so you could put the t down in front.
So do we have to do anything to show that the first two are kind of these, I guess, what are operations does
Yeah, and you could put,
Well, cause the first two were together.
which is why we added.
But if order operations says you have to do the first two.
Mhm. And if you put the log plus log base A of s on the end, that's okay, because you can add and subtract in any order. You just have to make sure it's a plus because it was from the top of the fraction. Other questions on those? We're going to keep practicing these. So let's do some more. So we are going to just keep expanding, same directions. So these things are multiplied, which means when I do the individual logs, we have to add them. So that's log base A of x plus log base A. I have a square root. I could write that as what power? Okay. So if I look at that, and we can go one more step, we know that 1/2 could come down in front. So that's log base A of x plus 1/2 log base A of x squared plus 1. Now it's really tempting to try to bring down this square. But inside this parenthesis, I have things being added together. They're not both being squared, so I can't bring the square down. Also, do we have a rule that allows us to break apart addition? No, we can only separate things when they are either multiplied or divided. So this is our final answer. We cannot break apart the addition, and we can't bring down the square because it has something else added with it. Is that one okay? Let's look at B. the top of the fraction, I have things being multiplied. How do we break apart multiplication? So it's the log of x. It was multiplied with the x plus 2, so we have to add the log of x plus 2. There's no base written on it, so it's assuming base 10. Then we're dividing by this, so what do we have to do? Minus log of x plus 3.
Put the 2 in the front of log.
Yes. I want you guys to try a couple. Everybody get that one? I want you guys to try C and D. So, the first one, a square root is like what power?
1/2.
1/2. So it's the same thing as saying x squared plus 1 to the 1/2 power. And we know properties of logs, that exponent would come down in front. So 1/2 log base A. Put that x squared plus 1 in parentheses to show us doing the log of the whole thing. Can you break that apart anymore? No, because they're adding. Can we bring down the square? No, because the whole thing is a square. All right, both of these things are on the denominator. So yes, they're multiplied, but since they're on the denominator, we will end up subtracting both of them. So you have log base A of x cubed, so the 3 would come down in front. This is also on the bottom, so I'm going to subtract log base A of x plus 1 to the 4th, so the 4 comes down in front. And that will be our final answer. D. When I'm looking at this, so if we break it apart, we have log base 2 of x to the 3rd, so the 3 comes in front. X minus 3 is on the bottom, so I have to subtract log base 2 of x minus 3 because those are subtracted. I can't break them apart with individual logs. So that's our answer. We weren't doing too bad with those when I walked around. I want to keep practicing, but we're going to go the other direction with these. Yeah.
So if it's on the denominator and you're multiplying, it's always going to be subtraction.
Yeah, so here's why. If anything's on the bottom, it gets subtracted, right? So you could think of it, I have to subtract everything on the bottom. And so yes, those two are multiplied, so they're added together. I just went ahead and distributed the negative to both terms. Any other questions? So that's expanding, breaking them apart into individual logs. Sometimes I'll say condense. That means put them back together into a single log. So when we get ready to solve equations, we have to be able to manipulate these. Sometimes we're going to need to break things apart, sometimes we're going to need to put them back together. Condense means I only want one logarithm. So this is log base 4. When I look at this, I have log base 4 of x minus, if this term is subtracted, where does the y go?
On the bottom.
Okay, but the z is added. Anything added goes on the top. So it's just log base 4 of xz divided by y. If I look at B. What does that have to do there? base b 1 time. This 4 would be the exponent on r, so that's r to the 4th. 5 is the exponent on s, but that was subtracted, so s to the 5th is on the bottom. Let's see. So, any coefficients would turn into exponents. So we have log base a. My 1/3 would be on my x, so that's x to the 1/3. You could write it as a cube root as well. Yep. This would be to a 2/3, or you could write it as the cube root of y squared. Either one is fine. This one's subtracted, so we would divide by the xy. Any questions about this so far?
Yeah, put parentheses around that or not?
Yeah, we should. I mean, technically, since there's not any addition or subtraction, it'd be okay either way. Alright, I want to put up a couple for you guys to try. So, condense for both of those. So we have log base a, we have an x plus log base a of 9, so that means times 9, so you could put x times 9 or you could write it as 9x, whatever you want, plus, so multiplied with x squared plus 1, minus, so we have to divide by the 5. Okay, so you can write it like that. If you threw parentheses around this whole thing, that's fine. Doesn't matter what order things are on the numerator as long as you have all 3 components. B, we have a log base 5. The 3 would go up on the u, so we have u to the 3rd. Plus, so multiplied with, we'll bring up that 4v to the 4th. So log base 5, u to the 3rd, v to the 4th. Again, you could have parentheses around that. Since it is all one term, you wouldn't have to. The only time you absolutely have to is if you have addition and subtraction in there. Okay. How are we doing with these? Let's go to a couple more slides I want to do. So if I ask you to evaluate this, log base 8 of 2 plus log base 8 of 4. We could try to evaluate each of those separately and add the answers together, or we could use our properties of logs. If these logs are added, how do you combine them? The log base 8 of 2 times 4. 2 times 4 is 8. What is log base 8 of 8? 1. Okay, so sometimes it's easier to use those properties at the beginning. So on B, if I wanted to condense these, what would we have to do? So it'd be 2 over 128, or 1 over 64. So we talked about these yesterday. You can set it equal to x and change it to exponential form. or if you understand the meaning of a log, it's looking for an exponent. What this means is 4 to what power would equal 1 over 64? So 4 to what power is 64? 3. And then if it's on the bottom, it would have to be
Negative.
What if I gave you this question? Ln is natural log. Do you guys remember, I think you talked about in algebra 2, what is the base of a natural log? That's if you have the,
That's the normal.
yeah, log without anything, that's base 10.
What's the difference between a natural log and a?
Well, so natural log is abbreviated ln, but what it means is log base e. So, if the base is e, what happens when you have a log base e of e? They cancel, so what's my answer? So if you see that ln and it asks you to simplify, just remember ln means log base e. Last one, I just want to keep practicing using these properties. So let's say I told you, I know we could do these on a calculator, but if I'm asking you to use the properties. Log base 10 of 7 is equal to 0.8451. And I want to use that piece of information to find log base 10 of 49.
Well, 7 is, squared.
Yeah, 49 is 7 squared.
So then you should be able to square 0.8451.
We wouldn't square it. Remember, properties of logs, the square would come down in front. So that's 2 times log base 10 of 7.
Oh, that's what we had to do.
And then it'd be 2 times 0.8451. What does that give us?
So log base 10 to the 7th or whatever is equal to the 8.51.
Mm-hmm.
That whole,
Mm-hmm. Yep, I just gave you the decimal it was equal to. So we were trying to manipulate the original equation so that we could use that property. What if I wanted you to use properties for log base 10 of 700? I've given you log base 10 of 7. How could you rewrite 700? Seven times 100. Properties of logs, what would you do with that? These things are multiplied, how do you break them up? Okay, I told you in the problem log base 10 of 7 is 0.8451. Log base 10 of 100 means 10 to what power equals 100? So we get 2.8451. So just practicing our properties there. Any questions for me? So, there is a Math Excel assignment open. The first probably 2/3 of that assignment is like yesterday's. So change this into logarithmic form, write this in exponential form, evaluate these. The last third or so is using the properties from today. So most of it is more practice, like the handout you did for homework